Hello, welcome back to Cracking the Cryptic, and it's lithium ion again today. Lithium ion has featured quite a few times lately. There's one simple reason for that. Lithium ion's puzzles are excellent. And I am definitely not going to pass up the opportunity of having a look at another one. This is just an arrow Sudoku, but apparently not that easy. So we'll have a go at that in a moment. Now, that does remind me that we have an app called Arrow Sudoku. I think there are some puzzles by lithium ion on it. I'm not 100% sure if my memory is right on that, but there are some really, really good puzzles on it. I know that. And if you get a buzz out of this one, solving today, and you want more Arrow Sudoku, it's a really good app to cut your teeth on and might introduce you to the rest of our apps, which feature now the worms as well. There's certainly Arrow Sudoku amongst those, including Zetamaths and loads going on there. We've also, of course, got some merch. You could get Cracking the Cryptic hoodie, sweatshirt, water bottle, mug, mouse pad, Marty Sears Rat Run merch. I mean, there's so much choice and availability. Do check it out. And on Patreon, we have put up a list of the successful solvers of the Detective Pet Sudoku Hunt. Solutions will start from tomorrow for the tier 1.5 and above Patreons. To that, and there'll be a new Sudoku Hunt on the 1st of next month. And of course, before then, you can check out the Gridogram and Connections and Crossword videos on Patreon, including the Times Monthly Club Special and Saber's Listener. So those are very well worth looking at. But let's have a look at this puzzle. Diagonal Stretch by Lithium Ion. The first link under the video will give you a link to play it in our software. And the rules are as follows. Normal Sudoku rules apply. 1 to 9 will go in every row, every column, and every 3x3 box. Digits on an arrow sum to the digit in the attached circle. Repeats are absolutely allowed along the arrows. Let's get cracking. Well, I think there are 2 arrows in this puzzle which are write-ins. So here we've got 5 digits on the arrow. The important thing about those 5 digits is these 3 can't contain any repeats, nor can these 2. So if you work out the minimum numbers there, they're 1, 2, 3. The minimum numbers here are 1 and 2. And if you add that lot up, the absolute minimum, it gets to 9, which is, of course, the biggest digit we can put in a Sudoku cell. And I think this arrow is exactly the same in conception and execution. That's a 1-2 pair, this is a 1-2-3 triple, and this digit is a 9. And there's a start. Well, that's not too bad a start. We've made progress, we're underway. And it's probably going to peter out there. The 1 and 2 there and the 1 and 2 there are going to use up 1 and 2 for columns 7 and 8. And that's going to mean that 1 and 2 in column 9 are going to have to be up in box 3. 9 can't be in any of these cells, that one because it would be the same digit as that one. In fact, this digit that I'm highlighting here, and the same would go for this one, can't be 1, 2, and 3 in its box 5 avatar, and can't be 9 in its column 3 avatar. So those are 4, 5, 6, 7, or 8. This is going to be quite large. The minimum here is 1, 2. The minimum here is 1, 2. I'm going to write 6, 7, 8, or 9 there. This pair can't be 1 or 2. So they're both at least 3. If they were 3, 4, this circle would add up to 7. If they were 3, 5, this circle would add up to 8. And this circle cannot add up to 9 by Sudoku. So one of these is a 3. The other one is 4 or 5. What about this? I mean, these 3 could theoretically be the same digit, but practically they can't be. In fact, this one is in a box where 1, 2, 3 form a triple, so that's at least 4. This one is in a box where 1 and 2 are active, so that's at least a 3. And now there's only going to be 1 degree of freedom. 4, 1, and 3 would give us an 8 here, so this is 8 or 9. This is 3 or 4. This is 1 or 2. And that may be the most important finding. This is 4 or 5. Now, why might that be the most important finding? Because of this 1, 2, 3 triple that is now stopping this cell being 1, 2, or 3. No, that's not all that powerful. Okay, it does, however, stop these two. Just for a moment, I'm going to color the 1, 2, 3s light blue. So all of these cells are known to be in the category of 1, 2, 3, and there are 3 of those in every row, box, and column. So we've found the 3 in column 6. Oh, I thought I was going to do a deduction from that, and I pitifully haven't. No, sorry. The theory I had about this being a digit from 1, 2, 3 is completely wrong. Right. Maybe there wasn't much point doing the colouring. I shall remove it. Now, where do we go for cheese next? If they are from 1, 2, 3, this is at least 4, so's that. This digit is probably, yeah, I mean, there's something going on here. This digit is probably 3, because that would give these a tiny bit of freedom. What if this is the same as that, because they're both different from this one. Let's very briefly color the 1s and 2s that we know are 1s and 2s. Oh yeah, if we could just find a cell where a red 1 or a red 1 or 2 and a yellow 1 or 2 are looking at the same digit, and that had to be 1, 2, or 3, we'd really be laughing. But I have not found that with this quick 1, 2 coloring. There is a 3 in one of these cells. This digit goes there as well, and then it has to go into one of these 3, but it can't be red because of where it is in box 6. It could, in theory. It can't be 3 because, again, of where it is in box 6 and the fact there's definitely a 3 on that 2-cell arrow. So the only way this digit could be here is if it's 4. Let's just examine that for a second or two. Yeah, I'm not seeing a problem. Okay, I'm seeing a very small problem on this diagonal. That 1, 2 pair is looking at this digit, which therefore can't be 1 or 2. In fact, yellow can't be in this pair, so the minimum for these is now 1, 3. Combined with 1, 2 there, that gets us to 7 as a minimum. This digit is now not 6, it's 7, 8, or 9. And if I could remove... I'd like to get an 8, 9 double in the bottom, a pair in the bottom row, but I think it's a bit of a pipe dream. Where does this digit, let's make that green, where does that go in box 6? I think there's only one location. Those are ruled out by Sudoku. These are ruled out by pencil marks. That is ruled out because it would be the same as this. So that green digit must go here. That's a surprising finding. That makes me wonder whether I'm really missing tricks elsewhere. These, yeah, look, nearly. These 2 digits are the same and must therefore in row 4 go in one of these 2 cells. If they were there, this would be a 3, they would be 4 or 5, that would be a pair here. There'd be all sorts happening that would be useful. Just wondering in my head whether there's any point adding up these 2 arrows. Just because this pair couldn't use 2 digits from 1, 2, 3. The minimum there would be a 1 and a 4, I suppose. The minimum here, I suppose that could be 1, 2. This has a minimum of 1, 3 as a pair. No, obviously, sorry, these 4 digits couldn't be 1, 4, 1, 2 because they all have to be different. So I think maybe there is some merit in adding up these together. That's a minimum of 10. If they were 1, 2, 3, 4, there might just be a way to arrange that with 2 low digits here, 4 and a slightly higher one here. 10 is the absolute minimum. These have an absolute minimum of 1 and 3. They can't be a 1, 2 pair because of that. So the minimum for these two circles combined is 14. This digit, therefore, is at least 5. It can't be 9, so it's 5, 6, 7, or 8. And that's not quite as constrained as I was hoping for, if I'm brutally honest. Oh, where does yellow go in this box? That's a good question. Ah, it was worth colouring the yellows. Can't be there, must be here. And that's yellow, 1 or 2. And in these 3, one of which is yellow, we now know it's up at the top. Okay, that is getting a little more interesting. Yellow is in one of these 2 cells. One of these 3, one of these 3, one of these 5. Maybe it's not getting much more interesting. I should have got that ages ago, but still. Red is obviously in one of these 3 as well. Red is in one of these 2 and one of those 2. And then where's the third red? I bet it's on this line. Let's imagine not having red on this line. These 2 would have a minimum sum of 3 and 4. And that couldn't work on this arrow because these 2 have a minimum sum of 1 and 2, and then the arrow would add up to 10. So red must be on this line, and in fact it must be there. And now this is not yellow or red, not 1 or 2, therefore it's 3. This one is red in its box. This is now looking at a red and a yellow, so that's 3. This is red and isn't 3. Now we've got quite a lot of red in the puzzle. We're going to get another red there, another one there. Red is in one of these 2 cells. And we've got a 3 there and a 3 here. We know there's a 3 in one of those cells. Ah, this pair can't be 1 or 2 now. I'm still a little bit fixated by the total sum of these circles and their respective arrows. This pair could be 3 and 4. That would really force this arrow, but it's possible. This pair, sadly for me, could be a 1, 2 pair. And this one, which can't be 1 or 2, could be as little as 3. It seems quite likely. And that hasn't really shoved me forward. Right, we need to do something a bit clever. Right, where's 9 in this box? It's not much cleverer, but it's a bit. 9 can't be here or here by Sudoku. It can't be on these arrows because of the nature of arrows. These would be 9 plus something. So the 9 in this box is in one of those 2, and then the 9 in box 5 must be here. And now this digit can't be a 9. The 9 in box 2 is in one of those 2 cells, which isn't that helpful. But this 7 or 8 is quite interesting. Remember, we said this digit is at least 3. And I think we've got... Ah, no, this is absolutely great. These are total minima now. 3 is the minimum for that cell because of the 1, 2 pair. 3 is the minimum for this cell because of the 1, 2 pair. 1 is obviously the minimum for these 2 cells, and that gives us 8, which is the maximum here. So that arrow has done it for us. I didn't need to consider it together with this particularly. And now I've found that red is 1. And that means that yellow is 2. And what else does that mean? That's taken away the degree of freedom on this arrow, which must go 3, 2, 4. And culminate in a 9. That's going to give us a 9 in one of these two cells, 9 in one of these two. So lots of arrows are done now. This one, yes, 3, well, it's not done, but 3 can't be in this cell, but it had to be on the arrow, so it goes in there. Now one of these two is a 3, so we've actually ended up with a 1, 2, 3 triple up here, which has surprised me a little. 9 there. What about the rest of the column? Don't really know, actually. This digit can't be 1, 2, 3, or 9, and that's a remarkably unexciting finding. That one I could colour red. Doesn't really add to the sum of human happiness. There's a 1 in one of those cells. Oh, okay, 3 in this box is in one of those two. Again, there's a 1, 2, 3 triple in these cells. And that one can't be 1 and that one can't be 3. So everything else in the bottom row is 4, 5, 6 or 7, and I will include this cell on a single cell arrow. That one can't be 4 by Sudoku. 8 in this box is in one of these 3. If green was 8, which I rather suspect it might be, these can't be 4, and that rules 4 out of these. So we are limiting all of these circles to 5, 6, 7 or 8. Three in this column is either at the top or bottom. Oh, this is 5, 6, 7 or 8, but these two digits are at a minimum 2 and 4. Indeed, if they didn't have a 2 in, they would be a minimum of 4 and 5, and this can't be 9, so they must have a 2 in, and we can place it right there. This digit becomes a 1, that's got a colour. And we know there's another 1 in one of those two cells, little X-wing on 1s remaining, an X-wing on 2, not quite an X-wing on 2s remaining. Okay, now this arrow, if that is 5, 2, 6, 7, 8, this is 3, 4, 5 or 6. Well, it can't be 3, so the circle can't be 5. But annoyingly, it can be 4, 5 or 6. I've got a good question. Where's green in this row? Because it's not in this box where we've already had a green. It's not in this cell where the pencil marking won't allow it. It's obviously not in those cells either. So it's in one of these two cells, but if that was green, that would also be green on that single cell arrow. So this is green, and that means that one is green, and they are 7 or 8, and we're getting quite a bit of population of green suddenly. Can we take it any further? Probably not. Looks to me like there's a green in one of those 3. 7 or 8 though, that's quite highish. And it will resolve whether this is a 4 or 5 also. No, I have not got a Scooby-Doo how to resolve those. This is, if that was 5, this would be 4. I mean, that would be really interesting. If that was 5, this would be 4, this would be 6, this would be 8, this would be 7. We'd have 5, 4, 6, 7, and this would become 8. If this was 7 or 8, which is quite possible, this digit would have to be 6. Then this would be 4, this would be 5, and green would be 8. So if this is 7 or 8, green is 8. So this cell itself is not 8, because it kind of forms a 7-8 pair where green is the 8. Now 8 in the row is in one of those two cells. Oh, we've also got this one. Right, I'm going to colour that blue because it's the same both times. Where is it down here? Well, it's not 1 or 3. So it's definitely this digit and it's also there. So now blue is making a play into the middle. Those can't be blue. Blue is 4, 5, 6 or 7. It can't be green, so it must be one of these two. And then blue is one of these two in row 5. It's already one of these 3, 4, 5, 6 or 7. And in this box, it's in one of these two. We've got that blue and that blue ruling out those cells. So that's quite interesting. These are 9 and blue up here. I wonder if you can do this by general colouring from here on in. Like I could give 9 a colour, couldn't I? Yeah, I'm gonna. Let's see what happens. Those ones are definite 9s. I'm going to make it orange. These ones are sites for 9 within one of 2 cells. So's that one, and in this box, one of those 2. Over here, one of these 4, unfortunately. But we've, oh, I didn't colour that one. We've got a 9 there. Okay, that didn't go as far as would have been helpful. But blue, 4, 5, 6 or 7. So 8 in this final column is in one of these 2 cells. I mean, I'm tempted to think it's green, but I don't have any evidence for that. If it's not green, one of these 2 would be 8. One of these 2. If 8 is not green, we do get quite a lot of fulfillment on it. We've already got it there. No, I don't know. I mean, it's a bit too speculative, that. Right, I'm going to give this cell a colour. It's a new colour. It's not blue, yellow, red, green or orange. It's pink. Now, the reason I'm doing that is because these 2 cells in box 9 are there and there. That's the only places they can go, being from 4, 5, 6, 7, and those being ruled out. So that's blue, and that one is therefore pink, and is 4 or 5. And I didn't know that before. Now pink is sharing a cell with the orange 9 up here. And now, I was going to say the 8 in the column is in one of these. That just doesn't work because 8 could be green. Pink in box 4 is in one of those cells. Well, yeah, okay, I'm not quite finished with pink. Pink in box 7 has to be in one of these 3 because it's not 1, 2 or 3. It's a 4 or a 5. So then it has to be in one of these 2 cells. In box 8. Yeah, what I'm basically doing now is colouring everything in box 6 and then propagating it. So let's go mad on this theme. We'll make 3 grey. What are these? Grey, red, yellow in some order. What am I doing? I'm making 3 grey. These 2 are grey and yellow between them. Now I've got 2 cells left here in box 6. And my 2 colours remaining are violet and light blue. I'm finding this quite interesting. So I'm going to make that light blue and this one violet. And I don't know what the numbers are at all, but because I've got a lot of this colored in colors, I know that violet is up here somewhere in box thingy, box 5, and then violet is one of these two sharing space with dark blue here. We've got this whole row colored, in fact, now. Annoyingly, 2 of them are shared, but that's the way the cookie crumbles. I might have gone a bit too mad on the colouring. There is every chance of that. Green is 7 or 8. I wish I knew which, because that might let me put some colour into this cell or something. Is violet restricted here? Yes, violet can't be 4 here. So violet, violet can never be 4. But maybe dark blue can be. I don't know, is this interesting? It feels quite interesting, if I'm honest. What do we have left to attribute in box 5? We have light blue and pink. Pink being 4 or 5. These ones are a combo of light blue, violet, and what's the colour? Green. And that means 8 is either light blue, violet, or green here. I don't know. I think I'm more confusing myself than throwing light on the puzzle at this point, which is a shame because that's all I was trying to do, is understand what I'm seeing and work it out. And I think I've really complicated matters now. Somebody will be pointing out in the comments the absolutely straightforward move that I'm not making, but there we go. All I can do is my best. I can't do any better than that. There was a 3 somewhere in this box. No, is there an arrow that I'm not working? So green and pink are both either at the low end of their range or at the high end. If green is 7, pink is 4 for this arrow. But if green is high, 8, pink is high, 5. So that would be 5 and 8 potentially. You see, if there's 7 and 4, in the central row, that's 4 and 7 having been used up. This would be a 5-6 pair, and light blue would become 8. If, on the other hand, these are 5 and 8, well, I don't know, but those are the 2 possibilities, and either light blue or green is 8. So in this column, 8 is in one of these 2 cells, and this digit, which is violet, is not 8. It is 5, 6, or 7. Now, I was very excited about violet not being able to be 4, but I'm a bit less excited now. This can't be violet because of the arrow, you fool. Right, that's fine. Yes, the arrow there, if that was violet, that would also be violet, but it can't be. So that's not violet, that's dark blue. And this 4 is not dark blue. It's either light blue or pink. This cell is violet. And we know that violet here is 5, 6, or 7, and here it's 4, 5, or 6. So we're crystallizing that it must be 5 or 6. And on this arrow, this digit is now not 6, it's 7 or 8. And it's not green, it's the other color that's not green. Do I know what that other color is? Oh, we now know I didn't. Oh, this isn't 7. Yes, that 7-8 pair is looking at this cell. So dark blue is not 7. Violet and dark blue are a 5-6 pair, including this cell, 5 or 6. This one, 5 or 6. That's a 5-6 pair in this column. So up here we have 4, 9, and that means 4 is pink. There we go. And now green is 7, and that is the sort of useful thing I did want to find. This colouring thing did seem to be the way to go. It all hinged on that, and I couldn't spot it. In this row, we get 8, and that is light blue. Right. Now, this must be light blue in the central box, and be 8. This digit is obviously violet, 5 or 6, and in this column we've got a 4-7 pair left. There's a sort of X-wing on 4s there. That's using up the 2 4s in rows 1 or 2, and the 4 in row 3 will be in one of these cells. 4 is pink, 7 is green. Let's colour. Because the colouring has worked, I think. That is what I'm going to say. Even if you don't think I was very good with it, I got there with it. That's a 4 in the bottom row. This is not 4. What's this colour? Is this known? That can't be light blue. So we're down to green and violet. This could be green or violet. Green in this box, or 7 as we know it in the other language, is in one of these cells. This digit sees 21734 in the column, 8 in the box, and that doesn't tell me whether it's 5, 6 or 9. If it was 5 or 6, it would be violet. Okay, what about here? This is known. This is 8 in the row. There we go. And now these are a 4-9 pair, which we know to be the colours of orange and pink. That is an 8. This is vital, isn't it? That's an 8, and that's on an arrow to a 6, which is the digit that goes in violet, and that means dark blue is a 5. And lots of things are falling into place now. These in the bottom row are a 6-7 pair. This column needs 6, 8 and 9. This digit is 6 or 9. This is 6 or 8. This could be any of them. What have we had up here? Everything but 6 and 8, which are a pair there. This is a pink 4 that I haven't marked. These ones are 6, 7, 8. Ah, there's only one place for 8, and that's here. So that's tidied that up. 8, 3, 2, 5, 1. Not 9 or 7 according to the column. That digit is 6 or 4. 9, 1, 7, 5. Oh, this is a naked single. It sees 3, 8, 2, 4 in the column, 9, 1, 7, 5 in the row. So I can write in 6 there, and lots of digits fall into place as a result of that. Really a surprising number. In this row, that's a naked 4. This digit is 2 or 3. That gives us 9 and 4. Now, what I could do is colour a lot of these, couldn't I? What I'm going to do is actually remove the colour from those cells and then colour all known 9s orange, all known 4s are pink. 7s are green, there aren't that many of those. 5s are blue. 6 is violet. 8 is light blue. And now 4, 9, 3, 2, 1. This is 6 or 7. Well, that's one of violet or green, which we keep seeing over this side. I'm sure this is relatively... Oh, look, that's a 2, 3 pair in the column. 1 is somewhere at the top. What have we got? 1, 5, 7, 9 still to place. So this is 7 or 9. This is 1 or 5. This is 1 or 7. And this one, 5, 7 or 9. this is 5, 6, or 7 now. Has something, that's a 5, 6, 7, 9 quad. None of them can be 4, so that's 4. That really is straightforward if I could just see it, which I didn't. Right. That 4 in this column, we've got 2, 3, and 6 to place. They're not coming naturally. We need an 8 up here somewhere. Oh, I'm not done. Have I done all the arrows? Maybe I've forgotten to complete an arrow. No, I think they're all complete. So it's just Sudoku. Oh, this is a 6 in the column. Sorry, 6 is coloured violet. So that gives us 7 and 9 here. 5 and 6 above it. That gives us 7 and 6, 7 and 9 here. Right, let's throw the colour into these cells. 7 is green, 6 is violet. That 5 is blue. And in this column we have 5 and 8. That's the way to go. That gives us 1, 7. That's going to fix this set. 2, 3, 1. Right, so that 3 is not yellow. That's not red. That's not grey. 1 is red. 8 is light blue. 7 is green. 5 is dark blue. The 6, 8 pair are done by the 8. I'm going to complete the whole rainbow mission. That gives me a 3 here, 2 and 6. And 3 is coloured grey. I haven't done that for a while. 6 is violet, 2 is yellow. I hope I haven't made a mistake in the colouring anywhere. That one's not grey, this one's not yellow, and in fact we're going to finish with a 3 in the corner, and that's 3 in the corner, that's 3 in the spotlight, losing its religion, and completing our diagonal stretch. Lovely puzzle by Lithium Ion, not how I expected that to work out at all. I wasn't expecting a colouring puzzle or anything like it, and Lithium Ion surprised me. Super stuff. One of my favourite constructors, and I hope you enjoyed it too. Thank you for watching on the channel. Absolute pleasure to have you with us. Do join us again tomorrow. Bye for now.